Let's talk about something every single one of us has to deal with when we're building apps. Passwords, API keys, all that sensitive stuff. You know you can't just stick it in your code, right? That's a huge no-no. So today, we're diving into how Kubernetes handles this exact problem with its own tool, Kubernetes Secrets. Let's get right into it.
Okay, so this is the classic problem, isn't it? You've built your app, it's all containerized, looking good, but it needs a password to talk to the database. Where on earth do you put that password so your app can get it, but you're not just, broadcasting it to the world?
Now, in the world of Kubernetes, you're pretty much immediately pointed to two options, ConfigMaps and Secrets. And if you look at them on the surface, they seem almost identical. They both hold key value data. But trust me, how you should use them, well, they couldn't be more different. So let's really break down these two faces of configuration, your secrets and your ConfigMaps. Because getting the difference between them is absolutely fundamental to using Kubernetes securely.
Here it is, the core distinction. ConfigMaps, they're for your everyday, non-sensitive stuff. Think config settings, URLs, things you wouldn't mind someone seeing. And that data might even get written to the node's disk. But secrets, that's where Kubernetes puts on its security hat. Secrets are built for the sensitive stuff, and Kubernetes takes extra care, like making sure they're only stored in memory, never ever written to a persistent disk. This is a huge deal.
So how does it do that in-memory trick? With something called a TMPFS, which is just a fancy way of saying a temporary file system. It literally lives in your computer's RAM. What that means is, as soon as your pod shuts down or the node reboots, poof, that secret data is gone. It never touched a physical hard drive, which is great protection if, say, that drive ever got stolen.
Oh, and one more thing to keep in the back of your mind. Both Secrets and ConfigMaps have a pretty strict size limit. You've only got 1 MB to work with, and that's because all this data gets stored in etcd, which is the brain of your cluster. It's built for being super fast with small bits of data, not for storing giant files.
All right, let's move on to what is, without a doubt, the single biggest misunderstanding about Kubernetes secrets. So many people get this wrong, and it is so important to get this right.
So you go to look at a secret in a YAML file, and you see something that looks like this. It's just a jumble of letters and numbers, right? This is what base64 encoding looks like.
I mean, it looks kind of scrambled, doesn't it? Almost looks encrypted, so it's probably safe to, check this file into Git or paste it in a Slack channel, right? Wrong, so wrong. And if you only remember one thing from this whole explainer, please let it be this. Base64 is not encryption. It's just a way to make sure binary data can travel safely through text-only systems. It was never designed to hide anything. It provides zero security. And here's the proof. Look how trivial it is to decode. Anyone who gets their hands on that string can run this one simple standard command and boom, out pops the original plain text secret, in this case, admin. No password, no key, nothing. It's wide open.
I love this analogy. Think of a base64 encoded secret like a password you wrote on a postcard. Sure, the mailman can deliver it, but literally anyone who handles that postcard along the way can read your message. It is absolutely not a locked safe.
Okay, so now that we've hopefully stomped out that dangerous misconception, let's talk about the right way to get that secret data from a Kubernetes secret into your actual application.
So you've got two main options here. First, you can inject them as environment variables. This is super easy to do, but it's risky. Those variables can accidentally leak into your logs, they can show up in crash dumps. It's just not ideal. Plus, they don't update automatically. If the secret changes, you have to restart your whole pod. Your other option is to use volume mounts. And because of those risks, the clear best practice is to use volume mounts, hands down. When you mount a secret as a file, you're using that secure TMPFS we just talked about, so it never hits the disk. And the real kicker, these mounts get updated automatically. So if you rotate a TLS certificate, the file inside the container just magically updates. No restart required. That's a huge win.
It's also good to know that Kubernetes has a few built-in types to help you organize your secrets. Opaque is just the generic default one, but you also have specific types for TLS certificates and for Docker registry credentials. Using the right type can help other parts of the system, like an ingress controller, know exactly what to do with that data.
Okay, so we've covered how your app should consume secrets. Now let's zoom out a little bit and talk about how we secure the cluster itself.
So remember how we said secrets are stored in etcd? Well, here's a scary thought. By default, they are just sitting there base64 encoded, not truly encrypted.
Encryption at rest is a feature you absolutely have to enable in a production cluster. What it does is encrypt the secret data before it gets written to etcd, which protects you even if an attacker gets a copy of your database backups.
Now, the best way to set this up is using something called envelope encryption with an external key management service, or KMS. It sounds complex, but it's a really clever idea. A brand new key is made just to encrypt your secret. Then that key gets encrypted by a super powerful master key that lives in a secure external vault, like one from AWS or Google Cloud. That way, the master key is never actually in your cluster, which adds a fantastic layer of security.
And of course, we can't talk about security without talking about RBAC, or role-based access control. This is your first line of defense. You have to follow the principle of least privilege. Don't give a service account permission to list all the secrets in a cluster. No way. Be specific. Give it get permission on only the 1 or 2 secrets it actually needs to do its job. This, plus using namespaces, is how you build secure walls inside your cluster.
Now, it's important to understand that while Kubernetes gives you all these great building blocks, it's not trying to be a full-blown, all-in-one secrets management system. For the really advanced stuff, we need to look outside the core of Kubernetes.
See, in most big companies, you need way more than just a place to store a secret. You need to know who accessed it. You need to rotate it automatically every 30 days. You need detailed audit logs. For that whole lifecycle management piece, the industry standard is to plug in a dedicated external vault, like HashiCorp Vault or one of the cloud provider solutions. This table kind of sums up your main options. You can stick with native secrets, which are simple and they're already there, but they can be a pain to manage with GitOps. Then there's the external secrets operator, which is a fantastic middle ground. It syncs secrets from your central vault into your cluster as native secrets, super GitOps friendly. And finally, for maximum security, you have things like the Vault Sidecar, which can inject secrets directly into your app's memory without them ever even touching etcd. It's more complex, but super secure.
And that really brings us to the final thought I want to leave you with. It's one thing to have your secrets stored in Kubernetes, but are they truly managed? You have to ask yourself about the whole lifecycle. How was this secret created? How often is it rotated? Who has access? Who's auditing that access? Answering those questions is what takes you from just storing secrets to actually mastering them.